over to Will Gulsby. He's going to talk on deer and turkey habitat responses to fire in pine and hardwood forests.
Okay. Yeah, I appreciate being invited to give this talk today. Wish I had time to go into a little bit more detail on each of these three main studies that I'm going to be talking about, but I had to sacrifice a little bit of depth at the cost of breadth because I wanted to try to highlight some interesting findings from each of these projects that are either recently concluded or being concluded right now. So just to start with a little bit of background, I think all of us here are well acquainted with the use of prescribed fire to influence habitat quality for deer and turkeys. And it's generally accepted that periodic fire, sometimes frequent fire in fact, increases or maintains deer forage and increases or maintains turkey forage, particularly in open areas for brooding cover, and then also can be used to maintain cover for nesting. So things that are less understood and kind of what I want to focus on today, especially the last 4 points, are optimal fire frequency for each objective. So we have some general ideas about how often we should be burning for deer and how often we should be burning for turkeys, whether that be for nesting habitat or brooding habitat. Magnitude of the cover or forage response. So we generally know that the response is favorable, but not as much work has been done to quantify the actual level of that response. The interaction between fire and the canopy and the resulting habitat quality for each of these two species. That's something Callie was talking about just before she got cut off, and she was talking about how higher levels of canopy can limit oak regeneration even when fire is present. And I've got some data today that I'm going to show you that the same is also somewhat true in certain circumstances for deer and turkeys. Then finally, fire responses or habitat responses to fire in hardwood systems has been less studied. And then another area that hasn't received much attention is how attractive these areas actually are in terms of numeric responses of deer and turkeys to areas that have been burned at some point in the past. So like I said, those last 4 are going to be the main ones that I'm focusing on today. So this first project that I want to talk about is being carried out in 5 loblolly pine stands in central Georgia. I'm broadly calling it the Midrotation Pine Project, and it's funded by Georgia Department of Natural Resources and Alabama Wildlife and Freshwater Fisheries. And Weyerhaeuser is also helping us out on this with some in-kind donations in terms of allowing access to their lands, implementing some of the fire and things like that. So like I said, we had 5 of these stands. In 2017, we experimentally thinned these stands down to 40, 60, and 80 square feet per acre of basal area during the summer of that year. And the idea behind choosing those different basal areas is we thought that the 80 square foot per acre basal area would represent a typical approach to managing stands that are industrially managed for fiber production. 60 would represent a thinning that would be implemented a stand where habitat was one of the primary concerns for species that require, open pine woodlands. And then 40, we wanted to start getting down into those real open pine specialist type species and create nearly savanna type conditions. So like I said, we thinned in 2017. We implemented a spring burn in 2018. That was really kind of in March at the transition from the dormant season to the growing season. But since it was in the month of March, we labeled it a spring burn. And then in 2020, we burned it again. And then half of the burn plots and also half of the unburned plots were also received an arsenal escort treatment during 2020. I'm not going to be reporting on those results today because that analysis is still very preliminary. So the majority of what I'm going to be focusing on is the results related to the effect of the different levels of thinning combined with those 2 prescribed fires during 2021. So that's that's 4 years after thinning and 2 years after 2 prescribed fires that were spaced 2 years apart. So I wanted to start out by just giving you some visuals on what these areas actually looked like when they were thinned to these different levels and then also burned compared to the unburned controls. So starting out with the 80 square foot per acre stands, The first thing that that'll immediately probably draw your eye is the amount of woody vegetation in that unburned area. And so this is, like I said earlier, these pictures were taken 4 years after these stands were first thinned. And then of course the burn stand down there on the bottom has much less woody vegetation. The overall height of vegetation is much lower. And you'll also notice that there's a lot more space between the clumps of vegetation that is, primarily right now covered in pine straw. So a lot of bare patches still in this stand that's thinned to 80 square feet per acre, probably because it's still, the vegetation response in the understory is still somewhat canopy limited. So then we go down the line to 60 square feet per acre. The same woody mess is present in the control 4 years after thinning and no fire. And then in the burn treatment, we start to see that we've got much greater coverage of understory vegetation. And that increases even further still when we go down to 40 square foot per acre treatment. So now let's actually get into some of those numbers related to deer forage in response to each of these. So beginning with total forage, you'll notice that these percent cover numbers, so this is percent cover of total deer forage, are obviously greater than 100%. And so that's just related to the way that we measure the vegetation along these transects, and overlapping vegetation can add up to greater than 100% cover. But the important thing to keep in mind is that these numbers are still scaled to one another. So, a 114 versus a 160, that is still a good representation of having much greater cover of deer forage in that 160% cover stand. So the general trend here, the first thing I want to point out is that as we go down from 80 square feet per acre to 60 square feet per acre, we get a significant increase in total deer forage. But then as we go from 60 down to 40, that total is statistically not different from the total deer forage in the 60 square feet per acre treatment. If we jump down here to the total amount of deer forage in the burn stands, we see the same trend with regard to basal area. Total deer forage is greater as we decrease the basal area to 60, but it doesn't really increase any further as we go down to 40. But if you compare these numbers to those in the unburned controls, you'll notice that on average they're lower. Well, this is something that we see, very commonly in deer forage studies. When you implement things like prescribed fire that are going to reduce some of the browse, the woody vegetation that deer eat in those stands, you're going to get a decrease in the total amount of forage biomass that's available in those stands. But when you look at the forb data, you see that what you lose in terms of woody browse, you gain in protein-rich, very nutritious forbs that are very important in deer diets during the summertime. And so beginning with the unburned controls, you see we had essentially no coverage of forbs in that 80 square foot per acre stand that was not burned. And then it jumps up when we get down into the 60 basal area to 21%, and about 13% in the 40 square foot per acre stand. But the real benefit of fire is evident when you put up those numbers for forbs in the burn stands. So specifically, although forb coverage was lower in the 80 square feet per acre stand than in the 60s and 40s, it was still 27% greater than in the highest basal area stand. And if you go across the board from 80 to 60, we see a twofold increase in cover of forbs in the burn stands. And as you go from 60 down to 40, once again, there doesn't seem to be a huge advantage to thinning further when the goal is to stimulate additional growth of deer forage. Now going on down the list of vines, you can see that we had very high vine coverage in the unburned stands. Vines aren't as sunlight dependent, particularly as like forbs and grasses. So we didn't see a huge change as we reduced basal area in terms of percent cover on vines. And then as you jump down into the burned areas, obviously vine coverage is reduced. So this is, again, what we're seeing, why we're seeing a lower percent cover of total forage in the burn stands, because you're reducing some of that woody biomass. And the same thing was generally true for woody vegetation as well. So it was pretty even across the board in terms of basal area in the unburned controls. And then in the burn stands, it was lower, but then again, it would stay pretty steady across basal areas. So as I mentioned, one of the things that is less known about silvicultural treatments and prescribed fire effect on wildlife is how does it actually change their use of these areas treated in different ways. So we were actually able to pair each of these treatments with several infrared triggered trail cameras because our treatment units were fairly large. They were implemented on an operational scale, and document how deer use responded to each of our various treatments. And one of the really cool things that we saw is that deer use increased twofold in areas thin to 60 square feet per acre or less. And it also increased another 2 to 2.5 times in the burn plots compared to the unburned controls. So with all that being considered, thinning and burning resulted in up to a 4.5-fold increase in deer use of these treatment areas during late summer. So to kind of recap that first study that I just went through, we saw that deer forage increases down to 60 square feet per acre of basal area. We saw up to a 4-fold increase in forb coverage after only 2 burns once these stands were thinned, and up to a 4.5-fold increase in summer use of thinned and burned stands by deer. And so we would fully expect that as we apply additional fire to these burn units, that we'll likely see further improvements to these various functional groups of plants that were really interested in deer, and specifically in those high protein content forbs that deer use or prefer to such a significant degree during the summertime. And conversely, we could also say that the unburned stands, although the total forage in those stands is currently really high, we expect the height in the canopy cover of that mid-story to continue to develop to a point at which eventually it's going to be shading out all the vegetation that grows within a deer's reach. So that short-term advantage of having total forage be greater in those unburned stands will likely dissipate over time. As I mentioned at the beginning of my talk, one of the other things that we know very little about is the effect of burning in hardwoods on habitat for deer and turkeys. So this project was designed to address that. It was funded by Alabama Wildlife and Freshwater Fisheries and conducted by graduate student Mark Turner. I think I failed to mention the previous one was conducted by a pair of graduate students. Kent Keene was the first one that came through on that project, and now Dylan Stewart is concluding it. But back to the hardwood project, we had 4 mixed hardwood stands that were located on Barber County Wildlife Management Area. And when we selected these stands, we wanted to choose some that were realistic representations of areas where landowners, managers might actually want to implement some canopy reduction and fire. So we didn't want, obviously, to locate these in bottomland hardwoods for that reason. And we also we definitely didn't want to locate them on south-facing slopes because those areas are more likely candidates in this part of the world to be converted to longleaf pine eventually. So that led us to settle on upland slopes with a northern aspect that already had mature mixed hardwood forest present. So the first step we took in this project was to reduce the canopy, and our goal was to do that by about 30% on average. And so we did this by targeting trees with relatively low value in terms of providing forage for turkeys and deer, specifically sweet gum, red maple, yellow poplar, some others. I mean, we even selected some oaks for removal that had poor form or that were overtopped or crowded. So to achieve the canopy reduction, we initially tried to get a commercial timber harvest implemented, but our study plots were too small to attract any buyers on that. So we settled on using a girdle and spray approach, where we girdled the tree with a chainsaw and then injected either a 50-50 Garlon and 3A and water mixture, or a 50% Garlon 3A, 10% Arsenal AC, and 40% water mixture. And so the reason we use those 2 different herbicide mixtures is we wanted to test the relative efficacy for these types of applications. I'm not going to present a lot of results on that today. I just wanted to briefly mention that the mixture that did contain Arsenal was much more effective on the hickories we treated, though. but I wanted to keep the primary focus of this talk on fire. So we did the girdle and spray on any trees that were larger than about 4 or 5 inches. Anything smaller than that, you can see in the picture there on the right, we just felled it in place and treated the cut stump with this solution. And then finally, we retained most of our oaks that had good form, and then other species that produced mast that is used by deer and turkeys, like dogwood, black gum, persimmon, and so on. So before I get into the results, I just wanted to share one of the videos from a prescribed fire that we implemented in one of the burn stands, just to give you kind of a visual representation of what the intensity looked like when we applied fire in these stands. So, primarily we were using backing fires to keep the intensity low. We were also choosing our weather conditions accordingly. But our experience in burning in these stands, and those of you who have burned much in hardwoods probably have had the same one, that given the same conditions, a hardwood stand just in general is going to burn at a lower intensity than a pine stand. But overall, our goal is to try to keep these flame lengths between 6 and 9 inches and definitely under 12 inches in height. So here's a picture of one of our stands in summer 2019. So this was FSI, so forest stand improvement. We reduced the canopy via that girdle and spray technique. And then we had only applied one fire to this stand at this point, and that canopy reduction was applied in January 2019, and that fire was applied in the year that this picture was taken. So it was really surprising to us. Of course, the results varied from one replicate to another, but overall we saw that the seed bank in these hardwood stands was full of native warm season grasses and forbs that were beneficial both as a deer forage and for turkey nesting and brood rearing cover. And they responded very quickly to these treatments. So here's the data on deer forage biomass. Not going to go into as much detail as I did in the pine study, just kind of giving some overall summaries here. So if you see, compared to our control, both our FSI, so that's just canopy reduction, and our FSI burn, canopy reduction and fire, treatment resulted in a significant increase in the biomass of deer forage in the understory. So those numbers are in kilograms per hectare, and once you convert that to pounds per acre, the numbers really don't change much because, although a kilogram weighs more than a pound, a hectare is larger than an acre, so it kind of evens out. But overall, you see about a 5-fold increase in total deer forage when you reduce the canopy in these stands. And again, you're going to see a little bit of a lower value for total deer forage in the FSI burn stand because you have reduced some of that woody browse there. And when you break it down by growth habit, the results really bear that out. So if you look, starting in the top left, you've got change in cover of all plants, which we just talked about, and then you've got change in cover of herbaceous plants. So you really see that stair-step pattern where you've got really low coverage of herbaceous plants in the stands where we didn't do anything. We didn't reduce the canopy. We didn't implement fire. Higher still herbaceous cover in the canopy reduction stand. And then the greatest increase in herbaceous plants was in the stands that were both canopy reduced and burned. And then you jump down to those bottom two and you see a similar trend for both semi-woody and woody vegetation, with the greatest increase being in the canopy reduction only stand. So now talking about nesting and brooding cover for turkeys, the general goal to increase quality of nesting and brooding cover for turkeys is to move cover down from, over 1 meter to the ground level and up to 1 meter. So you really are focused on producing fairly dense cover 3 feet or less in height. And you want the cover over 1 meter in height to be relatively limited. And the reason for that is that that cover near ground level at less than 3 feet provides a lot of concealment cover for that hen and her nest. It provides a lot of protein-rich insects and forbs for those animals to feed on, while at the same time reducing that shrub layer allows that hen to be able to detect any predators that are approaching her nest, or her brood. And as you see, as we go from the control to the FSI only treatment and then to the FSI burn treatment all the way on the right, the conditions get better and better for a brooding or a nesting hen. So specifically, we're reducing the percent cover of visual obstruction from vegetation in that 1 to 2 meter tall strata as we go to FSI, and then further as we go to FSI burn, while we're increasing the cover in that strata that is from ground level up to 1 meter. And that's exactly what we were going for with this approach. In addition to that, as I showed you in the deer forage figures, we're at the same time increasing herbaceous vegetation at ground level that is important as a food source for these animals. So it's a win-win in this case. So one of the questions that we were also interested in addressing is, what about the oaks? So from our perspective, one of the things that we wanted to do is ensure that we were retaining the acorn production in these stands, which is obviously a very important habitat component in fall and winter for both turkeys and deer, while we were improving foraging and cover conditions at ground level. So as part of that, we classified the maximum scorch on each of the oaks in our treatment plots on a scale of 0 to 4. So that first category is a category 0, which means basically no scorch was apparent on that tree. And 16% of the trees in our treatment plots, in our burn plots, fell into this category. Category 1 is just some light scorch near the base of the tree. And by far, the majority of the trees in our burn units fell into that category where they just had some light charring of the bark. Category 2 is a little bit heavier charring with some bark deformation. And we had about 21% of the trees in our oak trees, specifically in our burn plots, that fell into that category. But one thing that's important to point out here is that even at category 2, these trees are still not experiencing cambium damage. That comes in category 3 and category 4. So a category 3 tree would have significant cambium damage, and a category 4 would have severe cambium damage. So only 5% of our trees fell into that third category, and 0% of our trees fell into that category 4. It's also worthwhile to note here that the majority of our oaks that did fall into the more severe scorch categories were, of course, the thin-skinned water oaks present in these stands, which is not surprising. So to kind of wrap that one up, canopy reduction increased deer forage in these hardwood stands by about 500% on average. When you combine that with fire, that increased coverage of preferred forbs, similar to the response that we saw in the pine thinning and burning study. Fire also improved brooding conditions for turkeys. And based on our results on the limited amount of cambium damage that we observed in our burn plots, and based on the trees that we selected for removal, we were pretty much able to retain the vast majority of the acorn production in these stands to provide fall and winter forage for deer and turkeys. All right, so this last study that I'm going to give a brief overview on is one where we're focusing on the interaction between fire, canopy cover, and turkeys on the Talladega National Forest. So in the part of the forest that we implemented this study on, the burn units on average were about 1,300 hectares in size. So a lot of aerial ignition was being used on this site. So there were two main topics that we focused on as part of this study. One was looking at how these burn practices, and specifically time since fire, influenced turkey nest success, and we accomplished that using artificial turkey nests, which I'll talk about in just a second. And then we also wanted to look at how turkey occupancy was affected by those same burning factors, specifically time since fire, with these fires implemented on a large scale. So we did that using baited camera sites during the summertime. So first, talking about nest success, over the 2 years of this study, we implemented 232 artificial nests across burn units. And we paired each of these artificial nests with a camera that was set to record video when it was triggered by infrared motion. So each of these nests basically consisted of a slight depression in the ground, and we placed 3 unwashed chicken eggs in that slight depression. The reason that we wanted to go with artificial turkey nest is that although tracking real hens in their nest and looking at success is beneficial and offers some really good insight, and is very useful in certain study designs. The limitation of that is the hen gets to choose where the nest goes. With an artificial nest study, we can systematically distribute these nests over the areas with a different combination of habitat traits that we're interested in. So in this case, burn units. So on to the results, we saw an overall predation rate on these nests, regardless of time since fire, of 25%. So that was 58 out of 232 nests. That should say 232, not 230. And there was no relationship between time since fire and nest success. And that was probably related to the fact that canopy coverage across most of our nest sites averaged over 90%. So basically the understory in these areas was canopy limited, and its ability to respond following prescribed fire was as well. With the limited sunlight available in these stands, the vegetation response was fairly minimal. Speaking briefly to our overall predation rate, that rate of 25% is fairly low. It's actually really low compared to studies of real turkey nest that typically experience rates of 60 to 80% nest loss due to predators. And the reason for that is probably simply because our nest didn't have a hen present. And we know that when a hen sits on a nest, that's an additional visual and smell or olfactory based cue for these predators to hone in on. So that's probably why that overall predation rate was fairly low. So just to give you a look at what we saw on some of these cameras, I've included a couple videos here. So in this first one, you can see we've got a coyote depredation of a nest. One thing that I didn't mention earlier is a drawback of using actual hen nest is that a lot of times you can't determine which species of predator was responsible because there's fear of getting in there and setting any kind of equipment up that would potentially flush the hen off of her nest, leading to the loss of that nest. So because we're using artificial nests, we could set up these cameras and get some good videos. But the reason I included this coyote video and this next one, which shows a gray fox depredation of a nest, is because using this artificial nest design, we actually documented greater nest depredation by gray foxes and coyotes than any other wild turkey nesting study that was previously done. In fact, gray foxes were our #1 predator in terms of these turkey nests. Opossums were #2 and coyotes were #3, with raccoons being right behind coyotes, which was kind of surprising to us because typically raccoons are considered the #1 nest predator for turkeys. All right, so like I mentioned, we also paired the nest aspect of this study with baited camera sites to look at turkey occupancy across these different burn units. So we had 180 sites where we had bait with cameras during summertime across 2 years. And we specifically were interested in looking at adult male and female preference for areas that varied in time since fire. We wanted to also look at poult to hen ratios in these various areas, but because we got so few photographs of poults, we weren't really able to do that. And we also wanted to look at the effect of burn unit size on turkey use of those areas, and then also on burn unit interspersion on use of those areas. And interspersion simply means how were these areas arranged relative to one another across the landscape. So what we found, and these are preliminary results, the graduate student Mariah McGinnis is still wrapping this up, but preliminarily we can say that adults are selecting for units that were burned in the current year and that they're avoiding areas that were burned 1 to 2 years prior. And so one of the reasons we think that that's probably happening is that even though, remember, these sites had, for the most part, over 90% canopy cover, immediately after the fire, you're reducing the litter layer and making it easier for these birds to scratch for food. So there's probably a foraging aspect that makes them attractive when they're burned in the current year. But because the stands are canopy limited, it probably, again, limits the ability of understory vegetation to respond in those first couple years after fire. You get a very slow response, primarily of woody vegetation. And so there's not much cover in those stands when they've been burned 1 to 2 years prior. And you've also reaccumulated litter, so the forage attraction isn't as much present at that point in time. So to kind of wrap that one up, fire likely offers little benefit to turkeys when canopy is limiting. And, you know, we've seen in other research where they've taken advantage of fortuitous natural disasters. Well, I guess in the case of nest success, it was fortuitous. Hurricanes are obviously bad for many other reasons, but there's been some data that's shown that, you know, a hurricane came through a site, reduced the canopy significantly in portions of the study area, and turkey nest success was greater there. And we also generally see across studies that hens generally select for areas that have lower canopy cover. They prefer nesting in those areas, and it makes sense because there's most often going to be greater cover and concealment for her and her poults and her nest in that area. Also, reduction in litter immediately post-fire probably makes these areas attractive. Any astute turkey hunter probably has seen this before. You know, if you've got a burn during the late dormant season or early growing season, turkey season rolls around immediately after that. We know that turkeys like to come into those areas and forage. So that's all I planned on covering today. To wrap it up, I just wanted to acknowledge Alabama Wildlife and Freshwater Fisheries, Georgia DNR, the U.S. Forest Service, and Weyerhaeuser for their funding contributions to this work that I presented, as well as the graduate students that carried out this work, Dylan Stewart, Mark Turner, Mariah McGinnis, Kent Keene, and Allison Coulter, as well as Dr. Bob Gitson and James Martin, who have collaborated with me on this work. My contact info is there if you think of anything after the Q&A session. And if you're interested in seeing some of those videos and pictures and research updates, I share those pretty regularly on my Instagram, and you can see how to find me down there if you're interested in that.
Thanks, Will. All right, I do have questions. Of
All right.
course, you start talking about turkeys, you know it's going to happen. With that, first question is, you said the deer usage was much greater in the burn stands over the control stands during the summer.
Yep.
Do you have any data on deer usage during the fall/winter when hunters want to see them on their property?
Not from this study, but my expectation would be, I've done some other research that shows that first and foremost, deer select for areas that are least pressured by hunters during the fall and winter time. Cover type factors into that. So, you know, and given two areas experiencing the same amount of pressure, if one has greater cover, visual obstruction, deer are going to prefer that one. But even in areas that provide a lot of cover, if they're hunted frequently, deer will avoid those and move away from them. So the answer to that is complicated because it depends both on the cover present in an area and the hunting pressure that's present there as well. But if you're managing an area specifically to provide, I don't think the question was specifically about this, but if you did want winter browse present, it would make sense to, in certain areas, lengthen your burn rotation over areas where you're trying to provide summer forage, because greater browse is going to be present there.
All right, thank you. Another question, what species of plants dominated the understory for the deer and turkey?
In which study did they say?
They did not.
So, you know, trying to think back in the hardwood stands, we got a lot more of, you know, we got some ragweed, some partridge pea, some native sunflower species, a lot of goldenrod, and then a lot of viney stuff as well, like, you know, Virginia creeper, trumpet creeper. Of course, some non-natives were present there as well. Fairly similar species responses in the pine stands, but we saw some more of the ice cream plants that I refer to as ice cream plants for deer in the pine stands, some things like pokeweed, ragweed. Those in particular, those two species were notably present at higher percent cover in the burn stands, and we think that that's probably why, even though forb coverage was similar between the 60 and 40 basal area units, that we saw much greater attraction in the areas that had higher coverage of those species.
Okay, So there are several more questions. I want to toss one more out there, and then we'll come back to these other ones when we have time or during the break, if that's all right.
Sure.
Okay, what size burn unit do you recommend for both dormant season and growing season burns for turkey?
There hasn't been a lot of work that directly has quantified that and looked at turkey responses to it. My general recommendation, just based off of my anecdotal experience and that of others, is somewhere in the neighborhood of 20 acres or less.